Welcome to Brain Vision.
So the frequency of a simple pendulum is f equals to 1 over 2 pi times square root of g over L, and we get that from equation 11.11b. So the pendulum is basically accelerating vertically, which is equivalent to increasing or decreasing the acceleration due to gravity by the acceleration of the pendulum. So the new frequency will be 1 over 2 pi times square root of g plus a, so that's the increase in acceleration, divided by L. So we know that this is 1 over 2 pi square root of g plus 0.35 g divided by L, or 1 over 2 pi square root of 1.35 g over L. So now we can take the constant, or we can take 1.35 outside. So we have 1 by 2 pi times square root of 1.35 square root of g over L. So that's equal to square root of 1.35 times f, where f is the frequency defined at the beginning of the problem. So that means if we evaluate this, we have a little bit of space here, so let's write down that. So this is 1.16 f. So it's 1.16 of the initial frequency. Now for part B, the new frequency will be again 1 by 2 pi square root of g plus a by L, where now instead of plus we have a minus sign, so g minus 0.35 g, and then we divide that by L. So we can carry forward the same calculation as before, and we see that we have 0.65 times 1 by 2 pi square root of g over L, which is square root of 0.65 f, or 0.81 f. So it's 0.81 of the initial defined frequency. All right, thanks for watching. I'll see you next time.